Before you listen to this portion of the video, make sure you have the Probability with Trees handout that is located in the lessons section of TalentNet. Okay, class, this is what it looks like. You'll have that. That's great. Stop laughing, Kevin. There are two reasons I wanted you to see me do some probability problems here, because in Chapter 4 you can solve probability problems without using the notation correctly, and I'm going to be testing you on the probability notation, so make sure you watch how I'm writing the solutions here. The second thing is I want to show you how easy it is to break down a probability problem with trees, tree diagrams, and then solve using the tree. Okay, so let's get started. I'm going to work number 3 on this handout. 1/3 of all deaths are caused by heart attacks. 2 randomly selected deaths are chosen. So this is number 3. And notice we know that the probability of death by heart attack is 1/3. Now if you're going to shorten an event by using just a variable, for example, if you wanted to call death by heart attack the letter H, you would have to define it at the beginning of the problem. From there on, you can use that event H to denote the event of death by a heart attack. So if I wanted to, since I know that the chance of dying by a heart attack is 1/3, complement would be dying by something other than a heart attack. So that would be H bar. And the chance of that happening would be 1 minus 1/3, which is 2/3. Okay, so first thing you do is note all the probabilities that you're given in the problem, and then try to build your tree. Now you want to build your tree based on a simple event. And dying by a heart attack is a simple event. Nothing else is going on there. So the first branch of the tree is going to be the first death that was sampled, and either that person died of a heart attack or not. At the end of the limbs of the tree, you put the event, and along the limbs you write the corresponding probabilities. Notice this branch of the tree only represents that first body that is dead. And then the next person, the second death, is represented by the second branch of the tree. Now, what a tree diagram does is it gives you your whole sample space. So even though this second person is only going to either die by a heart attack or not, you need to represent it in 2 different places, because the first person could have either died by a heart attack or not. And then again, we write the corresponding probabilities along the limbs. Notice the probability has not changed from 1/3, because if you're looking at all selected deaths, or all deaths, that's a large population, and the change is going to be so minimal that it's like you're selecting without replacement. So 1/3 here, the same probability for the next body. And finally, what you see when you get the tree diagram is if you follow each of the paths along the tree, you'll actually find the sample space. HH means you've got 2 deaths, both died of a heart attack. Following this path, H bar. This specifically means the first person died of a heart attack, the second person did not. Following the next path, you'd get H bar H, which means the first person did not die of a heart attack, the second person did. And finally, H bar, meaning both people did not die of a heart attack. So your tree diagram gives you the whole sample space for the problem, and then from there you can solve any probability question. Now, given question A, if we want to know the probability that two randomly selected deaths both died of a heart attack, we're looking for the probability of heart attack, heart attack. Now when we write this and you don't see a connector in between in probability notation, this is assumed to be an and question. So this is the first person died of a heart attack and the second person died of a heart attack. So looking at our tree, we need to decide which path gives us the result that we're looking for. And you always start, when you read a tree, you always start from the left to the right, just like you read a book. So we start here, and we want the first person to have died of a heart attack, and so we follow the path here. And we want the second person to have died of a heart attack, so we're going to follow that path there. So our path goes from the beginning all the way to the top. So we're looking at this element of the sample space. So back up to our notation here, if we're looking for the probability of HH, this is the same as the probability that the first person died of a heart attack times the probability that the second person died of a heart attack. Because again, the and in probability denotes multiplication, the multiplication rule, and this would be 1/3 times 1/3, which is 1/9. You can feel free to either write the answer exactly as 1/9, or if you use a decimal, you must make sure you round to at least 3 decimal places. In part B of this question, we are asked for a question that actually has an implied or in it. If we're asked what is the probability that one of the two deaths died of a heart attack, this question is actually asking the event one of the two deaths died of a heart attack, and it says exactly one, so I should make that clear. Exactly one of the deaths died of a heart attack means either the first person died of a heart attack and the second person didn't, or the first person did not die of a heart attack and the second person did. These are the only two events where we had exactly one heart attack. So since we have an or, as you know in your probability section, the or implies addition. So we're looking at the probability the first person died of a heart attack, the second one didn't, plus the probability that the second one did not, and the first one did die of a heart attack. Again, notice where I changed the or to a positive, to a plus sign, and now I've got these two different probabilities on the outside that you need to write that notation correctly. Then again, back to the table to see where's the event H bar, and you always read the table from left to right. So starting here, H bar would be the path H and then the path H bar. So multiplying the probabilities along that path, we get 1/3 times 2/3. And then we bring down the addition, and then this path, H bar, H is this path here. It's going to end up being the same result, but the path actually takes a different order, the 2/3 times the 1/3. I don't know if that box is in the way. And performing the multiplication and addition, we get the probability that exactly one of the deaths was a heart attack is 4/9.